Welcome to the Section 1.3 Video Notes. Functions, that's what it's all about. Okay, what is the definition of a function? This is a general idea of what it is. It's like a machine where you put something in and you get something out. Okay? You put something in and you get something out. It could be, for instance, a number that you put in and then you get a different number out. Alright? Okay. A function must always give the same output for the same input. That's what makes it a function. Okay? So this right here, if you have this machine and you put in a fish and it turns it into a turtle, in goes a fish, out comes a turtle, then if it's really a function, every time you put in a fish, you'll get a turtle. Okay? Every time you put in a fish, you get a turtle. Otherwise, it's not a function. If it turns a fish into a zebra, then a fish into a leopard, not good. That would not be a function. That would only be a relation. Okay? Maybe you put in a frog and it turns the frog into a turtle. That's okay as long as it always turns the frog into a turtle too. It can turn different things into turtles. That's okay, it's still a function. Maybe it turns a dog into a cat. As long as it always does that, that's okay. It doesn't have to turn everything into a turtle. But if it turns a fish into a turtle, it's always got to turn a fish into a turtle. Okay? So in math, equations, x is often the input and y is often the output. So you put in a value for x and it tells you what y equals. Okay, so input x, output y. Alright? And like we were just saying, the same input must always give the same output if it is a function. So, which one of these, just stop and think for a second before you listen to me tell you the answer. Which one is a function? This brown one or this pink one? One is and one isn't. So look at the list for a second. Pause the video if you need to. Decide which one you think is a function. Okay. The one that is a function is this one. That one's not a function, and I'll tell you why in a second. So 0, you put in 0, you get 4. Put in 1, you get 2. Put in 2, you get 1. Put in 3, you get 4. Two different inputs gave you the same output, but that's okay. That's like turning a fish into a turtle and turning a frog into a turtle. That's okay. A machine can do that. But it couldn't turn a fish into something besides a turtle. It has to always turn it into the same number. This one, the problem is it turns a 1 into a 2, but then it turns a 1 into a 1. That's different, two different outputs for the same input. That makes it not a function. Okay? So in math, you call the input values the domain, and the output values the range. Okay? So this is actually the same thing that I showed you on this paper, just drawn a little differently. So for the brown one, which was a function, remember, all these arrows are going to different they're all going somewhere to the output value that goes with it. But there aren't any input values with two different arrows going different places. So it's good. It's a function. It's okay that 0 and 3 both go to 4, because that's different. That's the same output for different inputs. That's allowed. What's not allowed is this right here. The 1 outputs a 1 and it outputs a 2. So that was not the one that wasn't a function. So if you organize it like this, domain, the inputs, and range, the outputs, none of the domain should be going, no members of the domain should be going to two different members of the range. However, this pink one is still a relation. So functions are always relations, but even if it's not a function, you can still call it a relation. So a relation is just a general word that you can always use for things. Okay, next thing. Is the number of dogs a function of the number of cats? If you want to pause again for a second and see if you can figure out which one is and which one isn't, that would be great. But I'm just about to tell you. So, situation A, 3 cats, 9 dogs. 4 cats, 12 dogs. 8 cats, 24 dogs. 12 cats, 36 dogs. 15 cats, 45 dogs. 6 cats, 18 dogs. So, as you can see here, the number of cats, well, you might have noticed that every time the number of dogs is 3 times the number of cats. So you could say the number of cats determines what the number of dogs is going to be. So dogs is a function of cats, just like y is a function of x a lot of times in equations. So if you know the cats, it automatically tells you what the number of dogs is. So dogs is a function of cats. Alright, and this one happens to be linear because it's always just exactly 3 times the number of cats. But it doesn't always have to be linear to be a function. Okay. This one over here, 3 cats, then there's 8 dogs. There's 4 cats, and there's 9 dogs. There's 8 cats, and there are 11 dogs. 4 cats, 13 dogs. 12 cats, 26 dogs. 7 cats, 14 dogs. That one is not a function, and think to yourself, why? Why is it not a function? We'll pause the video and think for a second if you need to. But this is why. There could be 4 cats and 9 dogs, and there could be 4 cats and 13 dogs. So just knowing the number of cats does not tell you the number of dogs. If it was a function, the number of cats would determine the number of dogs. You couldn't have different values for the number of dogs with the same number of cats. So this one is not a function. Okay, on a graph, what this is going to look like is something called the vertical line test. So we already talked about x's are generally what we call the inputs, and y's are generally what we call the outputs. So x value input, y value output. So what it means that there can only be one output for a certain input. On a graph, that means for one x value, there should only be one y value. Or that's just for any x and y equation. For one x value, that's the input, there can only be one y value, or one, which is the output. Okay, so on the graph, that looks like a vertical line test. So one of these is a function, one of them's not. And how you tell is a vertical line. If you can ever see the function crossing the same part twice, it's not a function. If the graph crosses twice. So look right there. That's a vertical line. And so let's say when x is 2, is y 5 Or is it 9? Or is it 12? That crosses 3 points. So that's definitely not a function. If it even crosses twice, it's not a function. So all the way in here, it's crossing at 2 or 3 places. So that shows that this green graph is not a function. This red one, does that ever cross at 2 points? No, so the red one is a function. If we did a horizontal line, it would cross twice there, and there, but it's not the horizontal line test, it's the vertical, because it's only if there's multiple outputs for one input, meaning multiple y's for one x. So the x value 2 gives multiple y values on that green graph, so that's why that's not a function. The red one is good. Okay. An equation is usually a function. There's some examples that aren't. Usually if it has a plus or minus in it. But let's practice evaluating a function. So sometimes you see a function notation like this, d of x or f of x or y of x, something like this, to show that to indicate that it's a function. But it might just be written as y equals or d equals, whatever. So evaluate just means plug in the input and see what the output is. So this one, we'll just say d equals 3 times 2 plus 7, which would be 6 plus 7, which would be 13. When c equals 5, d equals 3 times 5 plus 7, which would be 15 plus 7, which would be 22. C equals 11, then we'll say d equals 3 times 7 plus 7, which would be 21, plus 7, which would be 28. So write it in function notation. We would say d of 2 equals 13. D of 5 equals 22. And d of 7 equals 28. So the number in there is the input value that you're plugging in for the variable c. Okay, obviously this could get more complicated with fancier different equations, but that's basically how that works when it says evaluate. Just plug in the value of the variable. And that is function notation. If it says d of x or f of x, sometimes instead of y equals, you'll see a f of x equals. It means the same exact thing. I think you've seen that before though. Okay, and one last thing on your notes is what's the difference between discrete and continuous? And the difference is discrete, you only got certain specific values. So if you graph it, it'll just be dots at different parts on the graph. Continuous, it's continually at any point along this line. You could go at 0.001, at 1 3/4. You could go anywhere along the line. Any x value in there you could plug in. So it's infinitely many continual values. So this line is continuous. It's not just jumping from one point to the next. We'll talk more about that later. Okay, thanks for doing the notes. Make sure to bring them to class next time, and I'll see you later.